Okay, so I'm just going to kind of walk through some notes for today's activity. So this is the first part of Unit 1. So this is day 1. So really, what you're doing today is just evaluating um, models that illustrate how the motion and arrangement of particles differ between solids, liquids, and gases. So we're just kind of looking at those different states of matter, and kind of seeing what their differences are and what's maybe the same about them and why that is. So what is matter? You probably already know that matter is anything that has mass, and anything that takes up space. So it has to have those two attributes in order to be considered matter. So um, solids, liquids, and gases definitely matter. Okay, they have mass, they take up space. Things like love, um, fear, dreams, those kind of things. Those aren't matter, right? There's no mass; they don't take up space. And we know that all matter is made up of tiny little particles that we call atoms. So, one of the questions that we went over today in the session is how are solids, liquids, and gases different, and how are they the same? So, you probably know a few things about this already. This is probably a little bit more of a review. If you were present in today's session, you'll kind of get to contribute your ideas, kind of see what other people are talking about, and then I'll post some responses into the actual slides that will be posted. So they're not in this video, but they'll be posted in the slides. So you probably know. I mean, solids, they're hard. They don't change shape. Liquids can change shape. You can pour it into different containers that flows easily. You're probably thinking about water. And then gases, they're kind of different. Your first thing is probably your thought is you might not be able to see them, which is true. One of the main reasons why that is because remember those teeny tiny particles that are invisible, they're spread out. So it is really hard to see them unless there's just a bunch of them that are accumulated together. So that's why we don't really see gases, is because those particles they spread out so far that we really can't see them very well. So really, what we're trying to look at in this the first part of this unit is we're trying to figure out why what we see with our eyes, how can that be explained by what we cannot see? So most of the your brainstorming when you're thinking about solids and liquids and gases is probably things like that you can see, right? They're hard. They move, they flow, they don't move, they don't change shape. Okay, so a lot of those were things that you see. So what we're really going to look at throughout this unit is how can the microscopic particles help explain what we see on that macroscopic level. Okay, so I just have some images. These, right, when you think of an ice, what's really happening with those particles of water, those molecules, they're held tightly together, right? Just like you think a solid. The steam from the water is spreading out, right? It's expanding like a gas. So when we're talking about how we can kind of go from what we see to what's really happening on the microscopic level, there's this idea called the triplet of chemistry. And it's basically how there's these three kind of points. We have a symbolic level of chemistry, a microscopic level, and a macroscopic level. It kind of how these things are related. So when we think symbolic, we're really thinking about pictures. We're thinking about drawing molecules. What do they look like? Right? Kind of like this image here. Well, the symbolic picture, these symbols, what they're really representing what's going on the microscopic level. So you might see the different types of particles, for example. Like if we're talking about Kool-Aid, you have water molecules, water particles, you have sugar molecules, you have the dye particles. Okay, they're actually turning at the different colors. And then what's happening on this microscopic level can explain what we are actually seeing with our eyes. Okay, so why is it red? Well, because there's dye particles, right, in in the solution. Well, why does it taste sweet? Well, because there's sugar particles in the solution. Okay, so even though we can't see that um, with our eyes, it's a microscopic level. It actually contributes or helps explain what we do see on the macroscopic level. So, just to kind of familiarize yourself with this, with the different properties of the different states of matter, um, you're going to complete the interactive card sort. If you're present in the live lesson, this was done in a group. If you're by yourself watching this at another time, you can just you can click the link in the slides. It's also found in the instructions for today, and you can just kind of do this by yourself. It's probably going to be more of a review. There may be a few things that's new, but some of it will be review, but that's okay. It's just kind of to refamiliarize yourself with the information. So after doing the card sort, you should be able to kind of answer a few of these questions. Um, I'm not going to go over all of them because some of them are very you can easily get from the card sort. Some of them are just kind of opinions. Like number one, did you place anything in multiple categories? Why did you do that? Okay. Um, so number three, I do want to talk about how do you think the arrangement of particles in different states of matter is related to the properties? So this is just kind of looking at, well, if we know solid particles are really tight together, held tight together, how does that explain properties of a solid like ice, right? Well, it makes sense. I have an ice, let's say I have an ice tray that's in cubes. Well, it's those particles, they freeze, right? They become a solid. They're really held really tight together. They're going to maintain that shape, the cube or whatever shape your ice tray is. They're going to maintain that shape because the particles are held really tight together. Whereas a gas, those particles are spreading out, so the gas is going to take up the space of the room or the container, whatever it's in, right? It's not going to stay in one shape. That also kind of helps you answer number four. Um, and then number five is kind of the same thing. Why can salt liquids and gases flow, but solids cannot? Okay, it all has to do with that particle arrangement, how those particles are actually arranged. So this is just again a review, but it just kind of shows the pictures. So it's kind of could help you answer some of those discussion questions if you're struggling with some of those. So you have, um, like I said, our solids are really held really tight together. Gases are more spread out, right? So that kind of helps explain the behavior and kind of what we're seeing with these different states of matter. And again, this is just another picture that kind of shows the same thing. It's talking about how solids and liquids kind of have this fixed volume. They're always going to take up the same amount of space no matter what you do to them. Whereas a gas, okay, we can kind of change the volume. It'll spread out and fill whatever container that it's in. So what's next? After this live lesson or the discussion, you're going to complete this assignment here, non-Newtonian lab and drawing. It's just kind of a review of what we've talked about. You are going to submit this. It is for a grade. The instructions are self-explanatory. You're just kind of dragging and dropping some things into the document, just like you did with the card sort. It's very similar. Tomorrow is an on your own activity. So that'll be the States of Matter activity guide. It's found under the instructions for tomorrow. Or you can click this link in this PowerPoint here if you wanted to go ahead and do it. It seems don't be overwhelmed by the pages. A lot of them are instructions. A lot of them is just a video. You're going to watch a video and then answer some questions based on what you learned in the video. They're all very short, a minute or less length of the time for the video. So they're very short. And then you're typing everything into that same document, okay, where all the instructions and everything are, and then you'll submit that for a grade. Okay, so it's not a live lesson. You can do that at any time that you get ready to do that. If you have any questions about today's material, please email me. I can get back to you very quickly. And then if you, like I said, if you need to do, if you have any questions that you want to talk about, you know, via video chat, just let me know and we can easily set up a conference or a WebEx or anything like that. So good luck. And again, let me know if you have any questions.